Hello friends, in this video we are going to talk about the overall fiber dispersion. Dispersion is nothing but the spreading of pulse. But what do you mean by overall fiber dispersion and in which type of fibers this type occurs? So let's begin with the topic. Hello friends, in this video we are going to talk about overall fiber dispersion. We know that dispersion is nothing but broadening of light pulse, which plays an important and crucial factor in case of communication system, which is a optical fiber communication system. Now let's talk about overall fiber dispersion in case of a multimode fiber and in case of a single mode fiber. So let's first discuss the overall fiber dispersion in case of multimode fiber. So when we talk about a multimode fiber, the overall fiber dispersion is basically consists of a intermodal or chromatic broadening of pulse as well as it consists of intermodal broadening of pulse. So now let's take at the look of RMS pulse broadening, that is denoted by sigma t, as it is a combination of a chromatic broadening and intermodal broadening. So we have a formula, that is sigma t is equals to sigma c square plus sigma n square raised to 1 by 2, where the term sigma c is nothing but intermodal or chromatic broadening. The intermodal or chromatic broadening is basically the pulse broadening because of both, that means because of material as well as because of waveguide dispersion. But most of the time the waveguide dispersion is considered as a negligible dispersion, and therefore majority of the time the chromatic dispersion is somehow or approximately similar to a material dispersion only. So we can write sigma c is equals to approximately equals to sigma m. Now moving towards the second term, that is nothing but a sigma n, and that stands for intermodal dispersion or intermodal broadening of pulse. So when we talk about a multimode fiber, so in that case we require to consider the chromatic broadening of pulse as well as we require to consider the intermodal broadening of pulse. So this is what all about a multimode fiber, or we can say the overall fiber dispersion in case of multimode fiber. Now let's talk about the overall fiber dispersion in case of single mode fiber. As it is a single mode, that means only one mode or a single mode is allowed to propagate within a fiber. Therefore, in case of single mode fiber, the dispersion is entirely depend on a chromatic dispersion. Whereas in case of multimode fiber, it depends on both. It depends on chromatic as well as it depends on intermodal, because multiple modes are allowed to propagate within a fiber. But in case of single mode fiber, as only one mode is allowed, therefore the dispersion, that means the broadening of pulse, is depend only on the chromatic dispersion. Now because of this the bandwidth is get limited. Now when we talk about a transit time for a unit length of fiber, then we have a formula. Transit time is equals to 1 by c d beta upon dk. Now here c is nothing but the speed of light in vacuum, whereas beta is nothing but a propagation constant for a mode within a fiber which having within a core of the fiber basically, which having a refractive index n1, whereas k also stands for propagation constant, but now that propagation constant we are going to consider in case of vacuum. Now when we talk about the first order dispersion, then we need to substitute this value of transit time in the formula. So we have now dt, that is nothing but the total first order dispersion, is equals to dTg upon d lambda, where lambda is nothing but wavelength. Now let's solve this equation by substituting the value of Tg in dt. So the first order dispersion is calculated by substituting the value of Tg in the equation. So now we have dt is equals to minus omega dTg upon d lambda into d omega. When we solve it further, we get the equation as minus omega upon lambda d square d beta upon d omega square. So now here the value of beta can be taken as kn1 into 1 minus 2 lambda into 1 minus b raised to 1 by 2. So from this we can calculate the total RMS broadening of pulse. So the total RMS broadening of pulse can be obtained as G lambda L mod of d Tg upon d lambda. So this is what about the overall fiber dispersion in case of single mode fiber. So let's summarize the overall fiber dispersion in multimode and single mode fiber. In multimode fiber, the overall fiber dispersion is because of the two factor. That is because of the chromatic dispersion, that means a chromatic broadening, and intermodal broadening. But the chromatic broadening is because of the material dispersion and waveguide dispersion. As waveguide dispersion is negligible, therefore it is approximately equals to material dispersion only. Now when we talk about a single mode fiber, as only one mode is allowed, so overall dispersion is because of a chromatic dispersion only, which causes a limitation on the bandwidth. So this is what about the topic, that is nothing but a overall fiber dispersion. So I hope you understand this topic. So thank you very much for watching this video.